Welcome to First Take Math. My name is Brian Thomas. Tonight's lesson is going to be on area of a rectangle, and we're going to do part 2. Part 2 is going to be about decomposing rectangles. And essentially what that means is the area of a rectangle can be broken down into smaller rectangles, and the sum of the smaller rectangles will equal the total area. So what we're going to get at here is, I have a multiplication problem, and what I want to do is model this multiplication problem using the area of a rectangle, because the area of a rectangle is multiplying two pieces together. So to do this problem, 8 times 17, I'm going to draw a rectangle. Now, an 8 is not a very friendly number for some people. They're not really good at multiplying 8s. But if you think in terms of money, an 8 would be like a 5 and 3 ones. So a 5 and 3 would not be so bad. So I think I'm going to break it down to a 5 and a 3 this way. A 17, and I can think of this in many ways. I think I'm just going to break it down like in terms of money. I'm going to just do like really just about place value. I'm going to do a 10 and a 7. So I'm going to break that into a 10 and a 7 this way. Now notice this side still represents the total length of 8. 5 and 3 does make 8. And 17 is made up of a 10 and a 7, so that still is a 17. And what this is telling me to do is, this is telling me to decompose it into smaller rectangles. I'd actually break that into 4 smaller rectangles. Now to find the area of each rectangle, we just know it's length times width. Well, 5 times 10 would be then a 50. And notice this 5 would be the same thing over here. This would be 5. So 5 times 7 would be then 35. And we know this is 3. And since this is 10, we know this edge here has to be 10. So 3 times 10 is going to give me my 30. And we know that if this side's 3, this had to be 3. And if this side was 7, then this had to be a 7. And 3 times 7 would end up giving me my 21. From there, what I can do is add total areas up. For me, I'm more of a down person, so I go 50 plus 30. That's going to give me 80. And then 35 and 21 would be 56. And then I can add those together. And that would end up being 136. Okay. So notice how 8 times 17, we've probably learned to do that as 17 times 8. And we've learned it as 8 times 7 is 56. 8 times 1 is 8 plus the 5 is our 13. That's probably how most of us learned it. This doesn't take us too far in the algebra realm. A rectangle model will take us further into the algebra realm. So you need to get a habit from, instead of just multiplying like this all the time, think about practicing multiplication using the area of rectangle, because it can get you a long way down the road without great thinking. This next example I have 5 times 26. And again, the way I want to multiply this is using rectangular thinking. So I'm going to create my rectangle. And again, you can use any numbers you want. I like the 5 like it is. 5's a friendly number to me. I like to multiply by 5s. 26, that is not as friendly to me, but if I break it down by place value, that's a 20 and a 6. So I could break that apart as a 20 and a 6 if I wanted to. You could have used a 20, a 5, and a 1 if you wanted to. You can break it into 3 parts. There's no restrictions on that. I didn't break this side up at all. I just broke this side up into 2 pieces. So I broke the big rectangle into 2 small rectangles. So 5 times 20, a couple ways of doing that. You can count 25s. That's 20, 40, 50, 60, 80. Oh, did that wrong. 20, 40, 60, 80, 100. We've also learned a shortcut. Just ignore the 0. 5 times 2 is 10. Stick the 0 back in. You get your 100. Then 5 times 6 would end up being our 30. And we end up our grand total of 130. We've also learned that 26 times 5 could be done this way. where we get 5 times 6 is 30, carry my 3, 5 times 2 is 10, plus the 3 is our 13, and we get our 130 that way. The understanding is a lot more powerful, I think, if you use the rectangle model. But we kind of grew up with this because we were just taught that. Okay. So that's going to conclude our lesson on the area of rectangle.